we are going to start counting today, but before we do, we're going to kind of give a little introduction to why we care about even counting. All right. Hold on. I gotta move this a little bit closer. So basically, both in probability and statistics, we're going to be running an experiment or perform an experiment, complete an experiment, and then we want to interpret results. Okay, that's really what brings us here together. However, this interpreting of results can be quite messy. And so we can look at pure models, pure experiments, and we have probabilistic models, or we can collect data points and then run statistics on data points. The interpretation is the thing that we have to be able to do well. All right, and we need some tools in order to do that. All right, and we're going to start here, first of all, with the definition. Okay, so if we run an experiment or perform an experiment, there will be possible outcomes. Okay, and so we call the set, so you got to know what a set is, the set of all possible outcomes of a given experiment the sample space of that experiment. And we usually denote it S. You can call it anything, but we're going to call it S. All right, so the set of all possible outcomes is the sample space of an experiment. Different experiments have different sample spaces. All right, and I need another definition. Any subset of the sample space is called an event. Okay, let's look at some examples. So for examples, makes me happy. So let's have our experiment here, and then let's discuss the associated sample space. So first basic one is you flip a coin. And your sample space over here. So remember, it's a set. And we'll say S is equal. And if we can list it, sometimes we can. Sometimes the set's way too big to list. Or it's infinite. So sometimes we just describe it either in words or we describe by a formula. But in some cases, we can actually list them, and we will here. So the set here is a heads or a tails, right? So that is the sample space. All right, not terribly interesting, nor is this one, but this is one we will refer to a lot because it's a good one to define things with. Let's say we flip 3 coins. Flip, flip, flip. So here, our sample space, each outcome is a set of 3 things, right? And then it's the first flip, the second flip, and the third flip. So really, we care about the ordering of these things, right? And at least in terms of what's possibly in this set. So let's list them all. We could have all heads. We could have 2 heads and then a tails. Heads, tails, heads. Tails, heads, heads. And then we could repeat this exact same pattern, but switch the heads and the tails. Those are all the possible outcomes if I flip 3 coins. We could do this for 4 coins or 5 coins or 10 coins or any amount of coins. But as you can imagine, that number gets bigger and bigger and bigger the more you flip. Okay, what about this one? What if I said that you roll 2 dice, a red and a white? What is the sample space? Any ideas? I put my visuals up here. Nope, I didn't. I'll put them over here. I'll bring this sheet over. So this is what your sample space would look like. It's a set of all of these ordered pairs where the first roll is I'm going to associate with red and the second with white. And so as we can see here is that these two rolls are different, right? So there's two ways that you could roll a 2 and a 1. The red one could be 2 and the white one 1, or vice versa. There's only one way you can roll 2 1s and so forth, right? So from rolling 2 die, this right here represents my set of all of them. So our set is the things that are in there, the elements. Oh, sorry, got to go back to our class. So I could write it, as this set of ordered pairs, 1 1, 1 2, and so forth to 1 6, then 2 1, all the way down to 2 6, and all the way to 6 6, and so forth. Right? Now, often what we care about, because listing them takes too long, is actually the size of them, right? And so the sample space is the set, and then the size of S we denote often like this, or the cardinality of S. That's often something that we care about quite a bit. So in this first case, the size of S is 2. In this case, the size of S is 8. In this last case, the size of S is 36. Okay? Okay, so this is kind of like a introduction to what brings us here today. We run an experiment. That experiment can generate a set of outcomes. Hopefully we can talk about the size of those outcomes, and then we can talk about, and then becomes the question, so we can perform predictive stuff, understand stuff. So the question that we often have in this class is, how likely is an event for a given experiment how likely is an event for a given experiment to happen? I don't feel like I love the way I structured that sentence. How likely is an event to occur? Okay, in a particular scenario. Okay, well, the first thing is, if all outcomes are equally likely, and by the way, in these examples I have above, they are all equally likely. I'm just as likely to get a heads as I am a tail, right? I'm just as likely to get heads, heads, heads as heads, heads, tails. Very different than saying I'm just as likely to get 3 heads as I am to get 2 heads, right? Do y'all see the difference? Each one of these is an outcome. Getting exactly 2 heads is an event. That's different. Another way, let's go over here and look at this picture of the dice again. Remember when we talked about, so here, there are 36 outcomes here, and each one is just as likely as the other. I'm just as likely to get a 2-1 as I am to get a 1-2. So let's write that. So the likelihood, I'm going to go ahead and use the probability words that we're not saying. So the probability that I'm going to get a, sorry, I don't want to put that set there. I'm going to get this is 1 out of 36. Whereas the probability of rolling a 1 and a 2 is 2 out of 36. See the difference? Okay. I'm going to come back over here to where we were, and then let's kind of formalize that. So if all outcomes are equally likely, we say the probability of, yes, sorry, I want to write that. We say the probability of an event E to occur is, and we denote it this way, probability of that event E is the number of ways E can happen divided by the number of ways, a number of outcomes in the sample space. So the number of ways E can occur over the number of outcomes in S, or the size. So the size of the event E divided by the size of the sample space. Okay, so this is a big question for us, and we know how to answer that question if we can count the size of the event or the size and the size of the sample space. So what that leads us to is, this means counting is important and useful to us. So that's where we're going to now take a slight detour, and we'll come back to this question that we want to answer. How likely are things to occur? How is that data distributed? All that kind of stuff. And we're going to make sure that we're up to par on counting, because counting is hard. Can be hard. So we're going to go now. I'm going to come off of this page because that's really my intro.